So, third period class, make sure you follow along with all of these problems, and you can thank second period for doing a great job on these. Okay? Go ahead, group number 1. No words.
Okay, so your first step is to find the GCF of the two. And the GCF is cotangent squared x. You then factor that out, and then you're left with 1 minus cosine squared x, which is a identity. That identity turns into sine squared x. You then convert cotangent into cosine squared x over sine squared x. And then the sine squared x's cancel out, and you are left with cosine squared x. Ta-da!
Yeah.
Any questions? Any questions? Stay up there. Where did the 1 come from? Tell them, Andrew.
So the 1 came from when you factor out the GCF of cotangent squared x, it's cotangent squared x times 1 is cotangent squared x, and then it would be multiplied by cosine squared x. So what happens is when you multiply it out, it's 1 minus cosine squared x. So if you multiply the cotangent squared x by this, you get this.
Okay.
That wasn't a good explanation.
No, that was good. Just let me use these arrows. If you were to multiply that back out, Ethan, you would get this. They factored. Okay. Okay.
Great.
Very nice, guys.
We did it.
Next group. Next group. So 52.
You understand it better, so you talk. It's
okay. Honestly, I could have just said
Do you want to learn that you would need a break?
See what I'm saying? That's for the 1.
You're talking. I'll talk, yeah. I'm good with talking.
Does that make sense?
If you remember me.
Yeah. All right. Group number 2, you may begin.
Okay. So first of all, that's not the right answer. Thing, it's a typo. So change that before you start, because then you will suffer. Okay. You take out again the greatest common factor, which is secant squared x, and then those things can be identities. The tangent squared x plus 1 is an identity. And you change, do that. And then you're multiplying them by each other, which then equals secant fourth x.
Very nice. Do we have any questions before they finish? We're seeing the identity? Yeah. Okay, good. Very nice. Very nice. Snap.
Guys,
Snap.
thanks.
Number 53. Let's just keep it rolling.
Okay, so the first thing that you want to do is you see that the left side is more complicated. And so you do difference of squares for the top. So you have cosine minus 2 in parentheses and then cosine plus 2. In the bottom, you can't factor anything out, so it just stays the same. And then you can see that the 2 cosine minus 2 cancel out. And then you have cosine x plus 2, which is equal to what it should be. And so you can just say that it's good.
Okay, that was really fast.
Yeah.
So say that a little slower. It's all
Say it a
right.
little
Just
slower?
slower.
Okay.
And now that you have it written, point instead of right. That's good.
Okay.
Say it slower.
So the top part is difference of squares. You can see it up here. And so you split it into cosine minus 2 and then cosine plus 2. In the bottom, there's nothing you can factor out, so it just stays the same.
And then you simplify and cross out the cosine x minus 2 on the top and the cosine x minus 2 on the bottom. And then that's going to leave you with just cosine x plus 2, which is equal to cosine x plus 2.
Okay.
Yeah, it is.
Very nice, ladies. Snaps, everyone. Great job. Yeah, yeah. 54. Somebody want to write, Ethan?
I don't know what I'm supposed to be doing, but okay.
All right.
They're insecure about writing in front of people, I guess.
It's basically the same thing as the last one, where you're going to do difference of squares. So you have like cosecant x plus 1 and cosecant x minus 1 on the top, and then you can cancel out the two cosecant x minus 1s. So you just have cosecant x plus 1 left over.
And then you can take cosecant x plus 1 and make it into sine, so it would be 1 over sine x and then plus 1 on the outside. And then you can put the plus 1 over 1 and cross multiply, like put it over 1.
Oh.
And then you cross multiply, and so you get sine x plus 1 over sine x. And that's the answer.
You're not dividing.
You have to cross multiply with addition.
Okay. Talk through it one more time. Tell them.
Wait.
What part are you confused about? Like the whole, when you're adding
so it's
to
like
the common
1
denominator?
over sine x plus
Yeah,
over
common
1.
denominator.
Oh, wait. So why isn't it 1 over sine x?
Because you're
What
cross
part? Common
multiplying.
denominator?
You're turning two fractions
Oh, you
into
have
one.
to multiply it, but got it. Yeah. Never mind.
And just to make sure it's approved, can you draw your line and show equal to the other side
Yeah.
so we can keep it balanced? Perfect. Thank you very much. Thank you very much. Next crew.
I do not understand that at all. I refuse to understand that problem.
Number 55. Go ahead.
All right, when you're given a problem with three terms, first always ask, can it be factored? In this specific problem, it can be factored into tangent squared x plus 1, tangent squared x plus 1. And now, before we take it any farther, you got to ask yourself, are there any identities? And in fact, tangent squared x plus 1 is an identity, and which turns into secant squared.
Scoot it down just a little bit. I made it easier to see. There you go.
And now once you have it turned into the proper identity, you can multiply secant squared by secant squared and get secant to the fourth x, which checks out with the right side.
Okay. Any questions? You see what their first step was? Why they factored? Hold on one second. We good?
Where did the 2 go? It's from the 2 tangent.
Well, when you factor
Oh,
it,
yeah, gotcha.
Very nice, guys. Very nice.
We sound so stupid on this video.
No, because that's good. Because they're going to be thinking the same stuff. No, they wouldn't. I promise. 56. Begin.
Alright, so this is kind of similar to 55. You want to factor out. You get sine squared x minus 1 times sine squared x minus 1. And now both those are identities, and they turn into cosine squared x. And then you just multiply them and you get the answer.
Any questions? That's good. It's good. Good job, fellas. Factor, multiply, done. Next crew.
Okay.
It'll get a little harder from here on out, so make sure you focus.
Oh, okay.
Right. For this question, we have to reference back to what we have learned at the beginning of the semester. So it's factoring, and we can factor sine to the fourth x minus cosine to the fourth x into.
Yeah. Sine squared x plus cos squared x, and then that. Yeah.
Right, Forge?
No, that's right.
All right. And if we reference back to identity number 6, we know that sine square x plus cosine square x equals 1. So we can just take out the sine square x plus cosine square part because it's 1.
Yeah.
All right. Now, I'm going to reference something back to junior high that you probably learned. It is a minus b equals minus, parenthesis, b minus a. So we can flip sine squared x minus cosine squared x into negative. Parenthesis.
Yeah. Where?
Parenthesis.
Yeah.
Into this form.
Equals it.
And this is a beautiful form because if you look at identity number 10, it says cosine square x minus sine square x equals 1 minus 2 sine square x.
So
it becomes negative parenthesis.
What?
Add parenthesis.
So yeah, parentheses, right?
No, negative is out there. Negative is outside. Yeah.
There.
That's good.
It's good, yeah.
All right. And now if we take out the negative part, we have to flip them back around again, which makes them 1 minus 2 cosine square x. And there we get our answer.
Yeah, guys.
Yeah, so you flip them around, you make them something else, and you flip them back. That's basically the logic behind it.
Good job, Jim.
All right.
Give them some snaps because they did it right. I'm going to show you one smaller way it could have been easier, but they did it right. There's multiple ways to solve these.
I literally have no idea.
You guys are amazing. Awesome. Brilliant.
There are multiple ways to solve these. Let's do it one other way.
Yeah, those parentheses are.
Okay. They were right. You have to take this and do difference of squares method. I'm just copying them so far. They had sine 2x minus cosine 2x, and then sine squared x plus cosine squared x. So they just difference of squares method. And then identity. What do we know sine squared x plus cosine squared x equals? Equals 1. So we're just left with sine squared x minus cosine squared x. Okay? And it is difference of squares again, which is where they went and then they used the negative and flipped things around. I want you to memorize your identities. So if you remember, I think this is identity number 10.
Yeah, you have to flip it around to use identity number 10.
Huh? And that's why you use the negative.
Yeah.
Okay. They used negative 1. Okay. And they flipped it around to where you would then have cosine squared x minus sine squared x, because it has to be in this form to then equal 1 minus 2 cosine squared x. This is an identity on your sheet. This is not. So they used a negative.
Wait.
They used multiplying something by a negative, and that was able to rearrange our signs to where it was the identity that we needed.
So you did the same thing.
Yes.
But you said there's.
I thought there was a shorter way. There's not. Those guys are smarter than me. Okay. This is what you got to do.
Wait, but we don't know that.
The rule to multiply something by a negative to change your signs? You know that rule.
No.
We know it now.
Well,
America, we don't learn it.
All right? Not needed. 58.
Is that going to be on
college level? Because math is more than just calculating. There's a lot of logic. Math is a lifestyle.
58.
Alright. When looking at 58, you can see that the left side looks a little more difficult than the right. So the first thing we did is we factored out secant 4x minus tan 4x into that.
You can go over your line if you need to.
And then when we look at secant squared, it is an identity that turns into tan squared x plus 1. And then
So freeze here, because this is great. I just want y'all to see what they did. Secant squared can turn into tangent squared plus 1. That's an identity. So they just basically substituted. Now watch what's going to happen because of that.
And now that we can see that there's a tan squared x plus 1 plus a tan squared x and a tan squared x, so plus 1 minus tan squared x. If you look at the right side, tan squared x plus 1 and minus tan squared x, you can cancel out the two tan squared x's on the right side.
The right side, show them, cross them out.
Yeah, there, and
No.
right there. And so that leaves on the left side tan squared x plus 1 plus tan squared x, and on the right side it just leaves 1. So then when you add those two on the left side, you get 2 tan squared x plus 1 times 1 on the right side, which the answer would just stay the same. So it's 2 tan squared x plus 1 equals 2 tan squared x plus 1. The 2? That's what happens when you add the
Combine
2
like
tan
terms.
squared x.
That one's tough, but you did a good job, though. Give him some snaps. So look for substitutions. Look and see if you can say, hey, I'm going to substitute this in for that. You can do that. Okay, we have 2 more. They're both similar. So if you don't get 59, watch 60 again because they're both the same style.
All right.
They're tricky.
Do you want to explain it? Yeah. All right. So first, you find that you can. All right. You can see that this would be a factor by grouping thing because you got like the 3, 2, 1, nothing type thing, and then so it'd be CSC x squared would be your thing you take out. Cosecant, and minus 1 there, and then over here you just gotta go like bang, and then so you got that going, and then you like make how do I explain this? CSC squared x minus 1. So yeah, these two combine.
-1 there.
Yeah, implied -1. And then CSC x minus 1 going. And then, whoa, what is that? That's an identity, which is cotangent squared x. And then CSC x minus 1. Oh, look at that. That's your answer there. Checks out. Cotangent, whatever. CSCX.
Yeah, there it is.
Minus 1.
Oh my.
Bang. Check.
Okay, freeze for a second.
Alright, freeze it.
Do you see what they did? They factored by grouping. And when they factored by grouping, they got an identity out of it.
Wait, I don't.
What was the first step? Like, why?
Alright, see how like to find like greatest or whatever you can take out. So like if you do cosecant squared times cosecant, that gives you cosecant cubed, and then that times -1 is like, do you see
Negative
that?
cosecant.
Or you could also just like look what you're trying to get to, like, oh, obviously you got to get to that parenthesis, so then you just kind of like use those and see how to get.
What happens with plus 1?
What plus 1?
Show them how a negative times a negative turns into a positive.
Yeah, a negative times a negative turns into a positive. Like this, like 1 minus -1 is like, oh, it kind of looks like a plus sign.
Okay. We'll talk about it more in a second. Number 60.
All right.
Good job, fellas. That's exactly right, though.
I don't
All right.
understand this.
Okay. So this
Okay.
one's very similar. So watch and see if you can connect more dots here.
So this is exactly this, but with different letters. So, yeah, pretty much. So basically, you have to factor out secant squared x out of that thingy, just like here, and you get secant squared x out, and then you get secant squared x minus 1 minus secant minus 1 equals, and then multiply this junk to this junk, and then you get secant squared x minus 1 and secant what?
It's
It's
it's a 2.
Yeah, thanks. There you go. And then look, that's an identity. So then you get tangent squared x and secant x minus 1. There you
Very
go.
nice. Very nice. You got any questions for him? Ask away.
How did you get from the first step to the second step?
See, Mr. Smith told me that happens like that. So there you go.
Mr. Smith taught us at the first 2 weeks of school that when you are doing grouping, these two things become your first parenthesis, and these two things become your second parenthesis. Remember?
What?
Secant squared x minus 1 goes here. Secant x minus 1 goes here. Okay? Third period, if you have questions, write them down. We'll discuss them on Friday. Okay?
My prayers.